All right, this is module 24. This is areas of regular polygons. First thing I have to kind of recall is something from first semester geometry. And it says, what does it mean to construct a circumscribed circle? So keep that in mind. We are going to define that and kind of go through that. So first thing I have to introduce is center of a polygon. The center of a polygon is the center of its circumscribed circle. So with the previous slide, remember the definition of a circumscribed circle, each one of the vertices touches the outside of a circle. So in this case I have the vertex, each vertex is touching the exterior of a circle. And it's inside the actual circle. So we say the center of the polygon is the center of its circumscribed circle. The radius of the polygon, again, is going to be a point, the center, that's your center, C, and you do a line from the point, center, to one of the vertices. So I have multiple different radii that I can actually draw in this particular polygon, this six-sided polygon, hexagon. So radius of a polygon is the radius of its circumscribed circle. But again, you have to make sure that it goes from the center to one of the vertices. It can't go from the center to like the side of a polygon. That is not a radius. Another piece of vocabulary is something called an apothem. That's how it is pronounced, apothem of a polygon. And the apothem is kind of like the common theme going through what the height is, what the little h is of a triangle, of a trapezoid, of a parallelogram. This is your distance from the center to any side of the polygon. That's your apothem. And it has to be a perpendicular segment. That's why it's kind of analogous to a height. So we have basically the height, a little h of a triangle that can be formed within this figure. If I draw two radii, remember the radius of a polygon is drawn from the center to one of the vertices. So if you look at this, the red, that's a triangle. And the apothem acts as the height of the triangle. So that's your apothem A. Okay. The central angle of a regular polygon. A central angle of a regular polygon is an angle formed by two radii drawn to two consecutive, right next to each other, vertices of the polygon. So the cool thing about this is that when you do this, you actually form triangles. And the way you figure out areas is actually by finding areas of triangles and then manipulating it in a certain way. So, but central angle, this is your central angle right here. And there are many central angles. If I continue to draw radii throughout this polygon, I would have multiple central angles. And they're all going to be congruent because it's a regular polygon. That's the key, regular. So remember what regular means. Same side lengths all the time. All the time, same side lengths. Okay, so just to get a little bit of comfort with this, example 1, we have in the diagram WXYZ is a square. So we know it's a regular polygon, and it's inscribed within circle with center P. It says identify the center, a radius, an apothem, and a central angle of the polygon. So do me a favor, pause the video, and see if you can do that right now. So here is your answer. So we have a center, that's center P. A radius, we have PY, so this is radii. PY or XP is indicated here, so this is a radii, this is a radii. The next thing is an apothem. Remember, the apothem is drawn from the center to the side, and it has to be perpendicular. So PQ is your apothem. And the central angle, remember, it's two consecutive vertices or two consecutive vertices, radii drawn to those two consecutive vertices, and the central angle would be this angle right here. Remember, naming an angle, you have to use 3 letters, and the vertex has to be in the middle. So you have the vertex in the middle, that creates your central angle. Example 2, it says, find angle measures in a regular polygon. In the diagram, A, B, C, D, E, I tell you, is a regular pentagon. So automatically, all the stuff we're talking about, regular, same side lengths. So, and it has 5 sides because it's a pentagon. Inscribed in circle with center F. It says find each angle measure. So do me a favor, go ahead and pause the video, see if you can figure out what the angle measures are. Okay, so to find the central angle, this is a central angle here. This is how you find a central angle. You take all of the central angles that are created within the polygon. So I have 1, 2, 3, 4, 5 central angles. 1, 2, 3, 4, 5 central angles. We know that all those central angles are congruent because this is a regular polygon. If you notice, all the central angles create a circle. What does a circle measure in degrees? 360 degrees. So you would do 360 degrees and divide it by the number of central angles that you can create, which in this case is 5. This is always going to be the number of sides in the polygon. So n. You divide it by the number of sides. So this would be 72 degrees if you solved. So that's why AFB, your central angle, AFB, which is this central angle right here, measures 72 degrees. So let's get rid of some of this business here. So 72 degrees. AFG. Well, if you drop an apothem, what an apothem does, and this kind of shows, we know that an apothem creates a right angle. You have this segment here of triangle 1 and triangle 2 is the same. We also know that the radii are the same, so that means the hypotenuse of the triangle is the same, which means I can use the hypotenuse leg theorem to show that triangle 1 is congruent to triangle 2. The hypotenuse leg theorem is from semester 1. Now, I'm not going to make you prove things, but this is why you actually do what you do when you're trying to find angle AFG. All angle AFG is you take the central angle, whatever it is, and divide it by 2. That gives you 72 divided by 2, which gives you 36 degrees. What about GAF? So GAF, if we have, I'm going to copy this triangle here. We have a right triangle, and what I figured out is that this is 36 degrees. I figure out that this is 90, and I can also figure out, because we don't know what this is, that's what GAF is. So we have GAF. All I'm doing is I'm just taking this triangle here and blowing it up, increasing the size, and focusing in on it. All angles of a triangle add up to 180 degrees. So that means x plus 36 plus 90 equals 180 degrees. When I solve, I get x plus 126 equals 180. When you solve for this, you get x equals 54 degrees. Okay? And that's what measure of angle GAF is. So again, this is pertaining to a lot of stuff from first semester, but the main thing, the reason that this example, I gave this example is because you have to find out what central angle is a lot, and you have to divide the central angle by 2. You also have to know that the other angles that are created are triangles, so they all add up to 180 degrees. Okay, here is the important theorem of this module. It's theorem 11.11, area of a regular polygon. So the area of a regular polygon, n-gon, any sides from 3 up to infinity, with side lengths s, is half the product of the apothem, A, and the perimeter, P. So you multiply them. So you can memorize either this formula or this formula, because what this is P. It's the number of sides times the side length. So in this case, we'd have S, 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 S. We have 6 sides, so it'd be 6 times whatever the side length S is. But that's in just this case. Okay, so we're going to be using this formula a lot throughout this module. So let's get into our first one. It says find the perimeter and the area of the regular polygon. So I have the perimeter first and the area. The perimeter is supposed to be the easy one, but in this case you still have to do something to manipulate and find out what the side length is. Okay, so we're trying to find out this entire length here. But what I'm given is 6.5, which acts as the apothem, and I'm given 8, which acts as the radius. I don't know what this length is here, but I do know that I can use Pythagorean theorem to find out what this length is. So I'm actually going to do, this is going to be x, and this is going to be twice the value of x. Okay? So I need to use Pythagorean theorem to actually find out what x value is. So I'm going to do 6.5 quantity squared plus x is quantity squared equals 8 quantity squared. Okay, when I do this, I get 42.25 plus x squared equals 64. I do 64 minus 42.25, and that gives you x squared equals 21.75. Get rid of the squared, you take the square root of 21.75, and that gives you roughly around 4.7. Okay, is your side length. So that's the hard thing about this one. So this, we say 4.7, that means this has to be 4.7. So if that's 4.7, that means this entire length is 9.4. So we can actually figure out perimeter now that we have that length. So let's do perimeter first. What I see is I have 1, 2, 3, 4, 5 sides. So that's the number of sides, because remember, perimeter is number of sides times the side length. So number of sides in this case is 5. Side length is 9.4. So if I did 5 times 9.4, that gives me 47 units. And I do not have units, so you can just say U or units. It's up to you. So once we found that, that's actually kind of nice, because we're going to use that to find out the area. Because area equals 1/2 your apothem, which in this case we know, which is kind of nice. In some cases we don't know, and it's kind of tough to figure out. We know the apothem is 6.5. We know the perimeter, because we just found it out, is 47. So when we do this and multiply it straight through, we get 47 times 6.5 times 1/2 gives us 152.75, and that'd be units squared, because we're talking about area. So you can see that these can be a little bit challenging because of the amount of steps and the extreme amount of possibilities that can occur. In this, you're always going to get a right triangle. The problem is that some cases I might give you an angle, you might have to figure out the central angle, and you might have to use trigonometry to figure out one of the sides of the triangle. So it is a bit on the challenging side. Okay, this is example 2. It says find the area and the perimeter of the nonagon. So nonagon means 9 sides. What I give you here, 16 is acting as your radius, and we have 8.48 is acting as one of the side lengths, so I'm going to put 8.48, transfer it over here. Draw another radius, so I have 2 radii, and draw an apothem here. Remember, what the apothem does is cuts the radius in half. So if you have the radius cut in half, you get 4.24 for each one of the parts here, so 4.24. And we're trying to find out the apothem, because we need that for the area. We can find the perimeter pretty easily because we have the side length, but I want to figure out all the parts that I need to know first before I start calculating things. So in this case, what I'm going to do is I'm going to do 16 squared, because that's your hypotenuse. That equals the apothem squared plus 4.24 squared. So once you have this, you solve, you get your apothem is equal to 15.4. So A is equal to 15.4. Okay? So once we know that, that's your apothem, then we can actually find the area in the perimeter. So let's do perimeter. So that's the number of sides, which is 9, times the side length, which is 8.48. You multiply it, and you get 76.32 units. For the area, that's going to be your 1/2, your apothem, which we found out to be 15.4. Multiply that by your 76.32. That will give you 587.7 units squared. Okay, so that one wasn't too bad. It was a Pythagorean theorem. All right, so for this one, it says the apothem and the radius of the regular polygon are drawn. Find the area. So I know I have the apothem here. I have a radii here. So I need to find out the side length here. You can call it x, you can call it s. Again, we're going to use Pythagorean theorem because remember the apothem drawn gives you right angle. So I got 2.2 quantity squared plus x quantity squared equals 2.37 quantity squared. When I solve for x, I get 0.88 for part of my side length. Remember, to get the entire side length, I have to multiply that by 2, which gives you 1.76 is the entire side length. So we are trying to find the area. That's all we're trying to find. So I have to do 1/2. My apothem, which have been given, is 2.2. It's a regular polygon. How many sides do we have? Well, let's see. We got 1, 2, 3, 4, 5, 6, 7 sides. And the side length, which we just found out to be times 1.76. When I multiply that through, I get 13.552 units squared. Okay, so it says find the perimeter and the area of the regular polygon. So it says a regular nonagon is inscribed in a circle with radius of 4 units. Find the perimeter and the area of a nonagon. So it's exactly the same thing as what we just did. It says find the measure of the central angle. This is the 6 steps that you're going to be using, the multiple steps that you're going to be using to find out if you only know, like in this case, we only know a radius is 4 units. So we have to figure out what the central angle is. So what I know is it's a nonagon. It's 9 sides. So finding the central angle, remember finding the central angle, we did 360 divided by the number of sides, which gives you 40. So with this, we have 40. It says find the lengths of the legs of the triangles. Well, in this case, that's where we have to take one of these triangles. We know this entire angle here is 40. The apothem, we don't know the length, but the apothem cuts this in half, so we know that this is 20 degrees, and we know this is 20 degrees. So we have to find the side lengths. So what I'm going to do, because I have to use SOHCAHTOA, I'm going to blow up one of these triangles. So let's blow up one of these triangles. So we have the radius is 4. That's your hypotenuse in the right triangle. We have our central angle cut in half is 20 degrees. So we need to find out what this length is here, because that's the part of the side. So what I notice is that my x is my opposite from 20, and the 4 is the hypotenuse. So which one of these would I use in SOHCAHTOA? Well, opposite and hypotenuse is sine. So I have to use sine of 20 equals opposite over hypotenuse. When you solve this, you get half the side length is roughly about 1.37. So if I need to find the entire side length, which is twice what I just found out, that means I'd have to multiply that times 2, which give you 1 or 2.74. So 2.74 is the length in terms of units of my leg. Okay, so here is kind of the blown up triangle that we have, and I found the leg was 2.74. I also have to find the length of the apothem, which I don't know here. There's a couple different ways I can do that. I can do it by SOHCAHTOA. I could also do it by Pythagorean theorem, because I know that this is 1.37 and this is 1.37. So, with this, what I'm going to do is I'm going to cheat a little bit and I'm going to use Pythagorean theorem. So 4 squared plus, or I'm sorry, equals, because that's the hypotenuse, 1.37 squared plus my x squared, because I have to find out what my apothem is. So, and that gives me my apothem. So we have the apothem, we have the side length, now we can actually find out perimeter and area. We didn't need the apothem for perimeter, but we do need it for area. So let's do the area, or the perimeter. So we have 9 times the side length, which we found out to be 2.74. So if you just plug this into your calculator, 9 times 2.74, that gives you 24.66 units, and that's it, because it's perimeter. So now dealing with area, you do 1/2 your apothem, which in this case we know is 3.8, and times that by your perimeter, which is 24.66. So 24.66 times 3.8 times 0.5 gives you a grand total of 46 point, let's round it to 9, nearest tenth, units squared. Those are your two answers. So this is how this can get very difficult, is because I can only give you one, and you have to give me the leg length, the apothem length, using trig and Pythagorean theorem, and then apply the formulas for perimeter and area to find out the different parts. Okay, for this one, what I noticed, this is a regular triangle. So we have 4, because that's what the Pythagorean theorem is going to give us. So this is a complicated region because we're trying to find the area of the shaded region. So I have to take the area of the circle, which is pi, times your radius, which is 5, quantity squared, and I have to subtract the area of the polygon, which is 1/2. Your apothem, which we find out is 3, they give us that, and times your perimeter. Well, if I know that this is 4 because of the Pythagorean theorem, that means this is 4, the entire length of one of the sides is 8. I have a pentagon, so it would be 8 times 5, which gives you 40. If I plug this into a calculator,